Hello, I am Lek Hanley from the University of Oulu in Finland. Our paper title is How Subtle Can It Get? A Trimodal Study of Ring Size Interface for One-Hand Drawn Control. In this paper, we mainly investigate the minimum interface with one-hand control for drone flight. Our computer is getting smaller nowadays, but the IoT device like the flying drones still require bulky controllers. So we question the way to get rid of those bulky controllers and making more body-centric device for drone controls. But the flight can move in four directional movements, which are longitudinal, vertical, lateral, rotational, and each movement has opposite directions. The rich command gives justification for two-hand operations, but it is counterintuitive to squeeze all the operations in a touch-based button. Before we go into our design process, we briefly explain the related work. In the rightmost column, researchers investigate the user acceptance to the drone as a companion device. As shown in the middle columns, the drone appearance has been studied. And in the leftmost columns, which is highly relevant to our work, they illustrate different models and controllers such as user emotions and raycasting controller. And we are the first work to design a minimum and body-centric interface and investigate the input models for flight controls. We consider three types of input models to strengthen the size of the device, which are touch-based interface, IMU-driven interactions, and force-assisted interactions. And we have some constraints here, as shown in the right-hand side. For IMU movement, we cannot employ yaw movement because it will conflict with the user walking posture. And the force spectrum, force-assisted interactions, cannot be divided into numerous levels as it will be erroneous. Then we carefully consider this combination and propose four candidate solutions and implement them on smartphones. M1 is unit-modal, which is touch-based interaction with two hand buttons. M2 is bimodal, utilizing touch and wrist rotation. M3 is trimodal, using touch, wrist, and force interaction. And M4 is bimodal, utilizing wrist and force interactions. M1 is our baseline, which emulates the tangible two-hand controllers. And M2, M3, M4 are one-hand buttons controllers for our research purpose. With the four interaction techniques, we run a pilot study with 12 participants. Each participant performed 5 unit flying tasks: down, up, left rotate, right rotate, left and right rotate, with 3 repetitions. We measure the completion time, wrist rotation, interaction footprints, and user workload in 4 conditions. And we evaluate the results with one-way ANOVA and post-hoc analysis. The full details can be found in our paper, and we only highlight our key findings here. For the completion time, M2 is not significantly faster than the baseline of M1, but M3 and M4 are considerably faster than M1. Regarding the wrist angle, M3 is the most subtle interaction. Finally, M3 and M4 demonstrate interaction footprint within a thumb-sized buttons. So, who is the winner? M3. According to the design clue collected in the pilot evaluations, we implement the selected method M3 on a ring-shaped prototype for hands-off and single-hand interactions in outdoor and mobile scenarios. Rather than an opportunistic approach to putting sensors together, we systematically measure the interaction area in our pilot study. The rightmost column showed our ring form design and a demonstration. As the form factors change from a smartphone to a ring form device, we need to run another evaluation study to understand those changes. One-way ANOVA shows that there exists statistical significance in the effect of the form size to the completion time, and the ring form device is at least 27% faster than the smartphone condition in all the flying tasks. However, there is no statistical difference in the wrist movement, so both conditions maintain gentle wrist movement within 47 degrees. Finally, we conduct a technology acceptance model to investigate the user perception of the new technology. Overall, the participants with the ring-form device give positive rating to the usefulness, ease of use, and intention of use. Before we end this presentation, a video is prepared to show the user interaction with our ring-form prototype for flying drone control. Users with our prototype can perform various movements like longitudinal movements, rotational movement, as shown in this video, like up, down, rotate left, rotate right. And it is very important to note that the user gesture is very subtle and gentle. If you have any questions, please feel free to contact me while the email shown in this slide. Thank you very much.